In Unit 2, opener number 2, we have a big line segment that's broken up into smaller line segments. Let's think about each of those smaller line segments as a term. And when we add up all of those terms together, we get an expression, and that expression will represent the length of our big line segment. The first term in our expression is x over 2. The second term in our expression is 5x. The third term in our expression is 14.7. The fourth term in our expression is x. And the fifth term in our expression is 19. That means that this little line segment is 19 units long. This line segment is x units long, 14.7 units long, 5x units long, and x over 2 units long. When I see x over 2, sometimes that can be difficult to work with, so let's think about that in an equivalent way. If I take x and divide it by 2, that's actually the same thing as taking half of x. And I think if we write it that way, it might be easier for us to work with later. So let's take all of our little line segments and add them up to form an expression that represents the length of our big line segment. We have 1/2 x plus 5x plus 14.7 plus x plus 19. In our expression, I see that we have a few like terms. We have 1/2 x, we have 5x, and we have x. And then we have a different set of like terms. We have 14.7, and we have 19. These 5 terms make up an expression, but we could actually write an equation, because the other thing that we know that we haven't used yet is we know that the length of this whole line segment is 59 units long. So let's take our expression and set it equal to 59 units long. The first thing that I'm going to do in order to simplify the expression on the left in the hopes of solving our equation for x to figure out there's only actually one solution that x can possibly be, that if I substitute it in to all 5 of those terms, we'll get a length of 59 for the whole big line segment. So let's simplify our expression first, and then we'll go through some steps of trying to solve our equation, figure out what that x value might be. 1/2 x plus 5x plus 1x is 6.5 x. 14.7 plus 19 is 33.7. There's a few different ways that we can go about solving this equation. One way would be guess and check. We can try to substitute in values for x, but I don't think that this actually turns out to be a nice whole number value for x, so I think if we try to do guess and check, it might take us a while to find the solution. We could solve by working backwards, which is a good strategy. But I'm going to solve for now using inverse operations. So what I'm going to do, since the 33.7 is being added, I'm going to subtract 33.7. But if I subtract something from the left-hand side of my equation, then I need to make sure that I also subtract it from the right-hand side of my equation. So on the left-hand side, I'm left with 6.5 x. And on the right-hand side, I have 59 minus 33.7. Let's grab our calculator and see what that equals. 59 minus 33.7 equals 25.3. Now we only have one step left in order to solve our equation. The 6.5 is attached to the x by multiplication. The inverse operation of multiplication is division, so I'm going to divide both sides by 6.5. Now my calculator doesn't use mixed numbers, so I'm going to take my 6.5 and enter it in as 6.5. 25.3 divided by 6.5 equals this messy number. I can represent that in 2 different ways. I could say x is approximately equal to 3.89. What that means is if I substitute 3.89 into my original expression, I'll get something that equals something close to 59, but not exactly 59. If I want an exact answer, then I need to represent my answer as a fraction. That fraction is 253/65. If I take 253/65 and substitute that back in for x, then I will get a line segment that's exactly 59 units long. It's always best to try to use an exact answer when you can. So this problem brings up a lot of good ideas. There was we took a lot of separate terms and we figured out which ones were like terms and we combined them to write an expression for the length of this line segment. Then we realized that we knew that the length of the line segment was 59. So we wrote an equation, and then we took that equation and we solved it for x to create a little bit more meaning for our diagram.